Project management students, welcome to chapter 6. Today we're going to be hitting up on project schedule management. In other words, how do we keep our projects on time? If you remember, the triple constraints of project management are cost, scope, and time. So time is valuable, time is money, time is everything when it comes to project management. So we have a lot of objectives for this, many of which are getting you familiar with some key concepts, diagrams, and approaches to managing the schedule. So we're going to be talking about what planning schedule management is all about. We're going to be talking about sequencing activities and how the activities themselves help us create things such as network diagrams or dependencies. In other words, if we've seen Gantt charts for most of our professional lives, if you're just getting familiar with Gantt charts now, that's a great illustration of sequencing activities and creating dependencies. So in other words, what task has to come before another task? We're also going to talk about how to use some other techniques in conjunction with Gantt charts, things like the program evaluation and review technique and other kinds of scheduling tools. We're also going to be talking about how agile approaches use schedule management tools in a little bit of a different way than traditional project management, traditional, i.e. predictive project management. We're also going to be talking about reality. We have goals for how schedules can run, and as we're all familiar with Murphy's laws, if it can go wrong, it will go wrong. We're also going to talk a little bit about how to use some project management software in terms of helping control the schedule, and also apply some of those lessons learned in here as well. So why are schedules important? Guys, think about what the schedule affects in a project. We have resources, we've got people, we've got machines, we've got other things that we need to get on the schedule, and we've got cost constraints as well. So no matter how hard we try, until somebody invents a time machine, it is the most limited resource. We can find more money, we can make a project bigger or smaller. We cannot control time. We've also got the issue of culture that plays in as well. Depending on what part of the country or the world you're from, urgency takes on a different matter. So, for example, in some cultures, time is relative. We have very little emphasis on getting things done in a timely manner. That's been a really big challenge for a lot of American companies operating in places with more relaxed cultures. So time can be challenging from that standpoint as well. So what are the time management processes? Again, it seems very familiar when we go through these different knowledge areas. We're going to be talking about planning a schedule. How do we plan to manage our schedule? How do we define what the right activities are? So that's part of our project management plan. What's the right order to do these sequences? And can some of these activities rather be done at the same time? So when we're sequencing activities, can we do more than one thing at a time? In terms of a given activity, what kind of resources will it require, and how long is a specific activity going to take? After we figure out all these things, can we determine a master schedule, and can we control it? Having great plans is wonderful, but if you can't execute them on the timeline you've promised, you're going to result in heartache and disappointment. What it comes down to is to be conservative when we're determining our schedule, meaning we're building in room for error. So this is a great delineation right from our text of the different tasks and activities that go underneath project schedule management. Of course, we've got planning, the inputs being things like the project charter, being our project management plan, things we've developed in previous areas. The tools and techniques are similar again. Expert judgment, data analysis, meetings to talk about it. How do you find out you're not on schedule, you're on schedule? Somebody's got to be gleaning that information. And the output from that area is a schedule management plan. And again, you could go through all these areas. I'm not going to read them to you because you're going to be reading them in your text. But what it comes down to is making a plan for how we're going to manage our time, determining what we're actually doing and in what order, so we define and sequence activities. How long each of those activities is going to take. Is it going to take 3 days to accomplish a task or 17? And that helps us build our master schedule. And finally, you got to control it. One of the most familiar and fatal flaws of project managers is over-promising and under-delivering. Everybody wants to present the best case scenario. I'll have this done in 2 weeks. When in reality, maybe you really need 3 or 4. I'm a fan of people who are realistic and will also build contingencies into their schedules. It's better to under-promise and over-deliver. So let's talk about, what does planning schedule management actually mean? When we get involved in creating a schedule management plan, what we're talking about is basically to have some sort of a model for development. And that could come from previous projects. It means within our particular organization, we may have a particular template that gets used to develop schedules. What kind of methodology we're using for scheduling? We're scheduling people concurrently, or are we scheduling people and resources one at a time, for example? What about our level of accuracy and units of measure? Are we down to days, weeks, months? To what level of granularity do you have to operate within your organization? What are your control thresholds? In other words, if you are getting in resources, for example, what limits time-wise are you allowed to have? Can you rent equipment by the hour, or do you have to rent it by the day? What about rules of performance management, for example? Are you able to evaluate somebody's performance based on a daily basis, or going more on an hourly basis and even more granular? What kinds of formats do people want in terms of the reporting? They want the reports down to 15-minute increments, which some customers do. And what about your process descriptions? When you're planning your schedule, how much detail do you need in terms of creating a schedule to be able to say these are the kind of processes we're going to be working with? So where we're starting for this, an activity or a task means that we are breaking something down on a work breakdown structure. We talked about WBSs in a previous chapter. So an activity or task, as the definition states, is an element of work normally found in the work breakdown structure that has an expected duration, a cost, and resource requirements. Generally speaking, an activity or task is one element on your WBS. So when you get into activity definition, you're going to be breaking down your WBS into more and more granular layers so that we can get cost estimates, so that we can really figure out what each step or process in our project is going to cost. Well, to that end, we need to be able to break down the activities to the point where we can actually break them into costs. In other words, if we get down to what we refer to as an activity list, it means that we're putting things specifically on a project schedule. We've got a name for that activity. When you see something on a Gantt chart, what is the task? How are we numbering them? Are we breaking down tasks in 1, 2, 3, 4, A, B, C, D? And what is the description? So the activity attributes tell us, for example, if some task had to come before that activity, where it fits, what sequence it has to be done within, what are its due dates, and how is it related to the overall activity. So when we see a Gantt chart, for example, we see an activity has a predecessor and something that comes after it. So some activities, for example, cannot take place until something else happens first. A milestone means that we have hit a point where we've accomplished something. So if we have a series of activities, for example, that result in us finishing part of the project, then we've hit a milestone. And it can sometimes take a lot of work, or they can be less aggressive milestones. And they're really great for getting a point where we can say we've gotten somewhere with a project. So our text gives us an example of getting customer sign-off on key documents. If you were building a house, a milestone might be that the foundation was finished, meaning you could start building the first floor. Sequencing activities simply means that we're putting things in the right order. In other words, if you're building a house, you can't start with the roof. You've got to start with the foundation. So we are building dependencies and also giving reasons for the dependencies. And the analogy of the house is pretty simple. If you have a foundation, you can build walls on a foundation. You cannot build a roof with no foundation or walls to put it upon. So we've got what we refer to as mandatory dependencies. So there are certain things that have to happen in a certain order. We also call that hard logic. And then there's discretionary dependencies, meaning they could be optional parts of the project, or there are things that could be done in a different sequence, and we also refer to that as soft logic. And that the next concept, external dependencies, which means we've got project and non-project activities. Let me give you an example. If we were building a factory and our labor was union labor, and the employees were mandated to go to specific union mandated training, that's an external dependency that has nothing to do with the project itself, but can still grind our project to a halt, because if we don't have people available and we're a union shop, we cannot continue on the project. So that would be an example of an external dependency. So we use things called network diagrams. A network diagram is exactly what it sounds like. It shows the logical relationship and sequence and activities. So the two main formats we're going to show you are arrow and precedence diagramming methods. It's pretty straightforward. So if we get to a typical network diagram, and we'll talk a little bit more about critical path here, but you can see that there are arrows that show us what way we can walk through the project. Here we've got several potential paths that can go through the project, and we're using arrows to go from one step to the next. Now, as we'll discuss in the coming slides, the critical path is the longest pathway through the project. In other words, if everything we were trying to accomplish took the longest possible route, there you have the critical path. So the critical path, in this case, you could calculate just by seeing which path had the largest number of days involved. The arrow diagram method, which you just saw, the activities are represented by arrows going from one place to the other. And again, it's showing you start to finish dependencies, or finish to start dependencies, I should say. Now, precedence diagramming is something we also see occasionally on things like Microsoft Project. It may look familiar. And network diagramming, you've got boxes that represent different types of dependencies, whether it's finish to start, start to finish to finish, or start to finish. It's best explained with an illustration. So, for example, we can see on the finish to start that task B can't start until A is done. And then we've got start to start, which means task B can't start until task A starts. So they have to start simultaneously. And then we've got finish to finish, which means task B can't finish until task A finishes. So they have to finish together. So, for example, if you are watching a movie, and if you want the sound and the pictures to end at the same time, they would have a finish to finish type relationship. And then start to finish means task B, the second task can't finish until A starts. So it's linear and sequential. So again, we see a lot of this in Microsoft Project, for example. Here's another way that we can use what we refer to as precedence diagramming methods. And again, it's a simple network diagram. Some programs like Microsoft Project tend to default to larger squares or larger rectangles. But here, for example, we see the paths that the project could take. The critical path, by the way, is always illustrated in Microsoft Project by default in red. That's the longest path through this project. So next we're going to talk about actually estimating how long an activity will take. So the duration means how much time the work is going to take plus elapsed time. What is elapsed time? Well, we generally assume, even though many of us work longer hours, that the work week is a 40-hour work week, plus we get weekends off. So nobody's actually working every hour of the day they're in an office, but we still count the time in days. So if it's going to take 7 days to finish a project, that doesn't mean you're literally working for 7 days. So it's actual time worked plus elapsed time. So the effort is the actual number of work days, the actual hours you are actually working on the project. And so effort does not normally equal duration because we cannot work 40 hours without stopping. Some people think they can, but most people don't. When we're getting into durations, I think one of the biggest mistakes that project managers make is not getting the people involved with the work and getting the estimates together. In other words, if you want to know how long it really takes to do something, ask somebody who normally does it. It's common sense. So another way to do this too, we refer to a 3-point estimate. And that means if everything went great, you had the most optimistic estimate in the world, plus the most pessimistic and the most likely. That's a 3-point estimate. Well, if everything lined up perfectly, we could get this project done in 5 days. If everything went wrong, it's going to take us 15. If things kind of came out in the middle, maybe it would take 10. That would be an example of a 3-point estimate. Our text also talks about PERT and Monte Carlo. We're going to talk somewhat about PERT. Monte Carlo simulations are really beyond the scope of this class. Not to say they're not important, but if your company is using Monte Carlo, you're going to be familiar with that technique. So some advice. What I think that really most of us have a hard time estimating. And why do I think that? Nobody wants to give bad news. Nobody wants to tell the boss it's going to take a heck of a lot longer to do this project than what you thought. We all tend to default to very optimistic estimates. if you get better at doing estimates, actually one of the best teachers in this regard is submit an overly optimistic estimate that you can't live up to one time. And if you're lucky enough not to get fired, you probably won't do it again. And that's a very crass statement, but that's really how I feel about this. I think at times we are definitely not realistic, and we tend to overpromise and underdeliver. So I encourage you to consider avoiding putting yourself in that trap and trying to be honest with yourself. And so use other people and experts to help you create these estimates, and the more detail you have, the better off you're going to be. So the bottom line is take time in scheduling activities and put some real time and effort into them, talking to people who know what they're talking about. So then we're on to developing the schedules, and we got a lot of interesting tools we're going to use here. Some of them you're going to be using all the time. We're going to be talking a lot about Gantt charts and critical path. In fact, I think critical path is so important that later on in this class, we're going to do a micro lesson on how to manually calculate critical path. Yes, Microsoft Project, Project Libre, and all these other wonderful software tools really are helpful in terms of critical path analysis, but every project manager should know how to do it manually as well. But what's our goal in developing a schedule is to come up with something that's realistic and achievable. So we're going to be talking about these techniques. So Gantt charts, every middle manager's favorite. It basically gives us a way to be able to display activities, start and finish dates, put into a graphical chart so we can wow all our fellow middle management friends when we put it on PowerPoint and make everybody look at it in the conference room. I'm being a little sarcastic, but it's one of the most well-known and used tools in business. Black diamonds typically are milestones, thick black bars are summary tasks, etc., etc. These rules are not hard and fast. Some people modify their charts to look a little differently, for example, but arrows definitely show dependencies. As we were talking about things like precedence diagrams before, precedence diagrams also are Gantt charts as well. So again, let's move on. Here's an example of a Gantt chart. You can see that there are dependencies here. For example, if we are looking down at task G cannot start until task C is done, and so on and so forth. This is graphical, and it's relatively easy to do. Not to say that all the capabilities of Microsoft Project and other project management tools are simple or easy, but they are somewhat straightforward. So it makes sense. So on the same token, because we can have different views within Microsoft Project, we can also change to a more text-based view where we will enter in specific information. You can type in tasks, add durations, and the diagrams will be created for you. You're going to see this as we play with this software as well. So in terms of adding milestones, again, one of the reasons we put milestones into whether it's a Gantt chart or a report, we want to show people that they're actually accomplishing something. I think there's a big psychological value to being able to document a milestone. Milestones, so I know this is a cliche management speak, but we want them to be smart, specific, measurable, assignable, realistic, and timely, or time. This chart demonstrates that we can use Microsoft Project not only to plan projects, but also to keep up with where we're actually at. You can see here that there were planned dates and actual dates, and we can see where we've either hit or slipped milestones. It's really a great tool. Now, the old adage in technology is garbage in, garbage out, so the tool is only good as the people running it. Critical path is one of the most misunderstood concepts in project management. Critical path is part of a network diagramming method, and it just means it's the longest path through a series of tasks. So it has the least amount of possible wiggle room in the schedule, also referred to as slack or float. So this is if you had this critical path, it would be the least chance for any kind of wiggle room or delays through the entire project. If you took that path, it would be referred to as the critical path. If you develop a series of potential paths through a project and sequences of events, the critical path is the longest path. It shows up in Microsoft Project as the red path when you view the network diagram. And if you see, for example, if you mess up any of the schedule in the critical path, the project is going to be behind schedule. You may have more slack or float in other paths through the project, but not through the critical path. So here's an example of the critical path. If you want to determine the critical path of these paths through the project, it's very straightforward. Path 2 is the critical path. It's the longest path through, has the least amount of margin for error. It's important to realize, too, that when we talk about critical, the word critical sounds like it means crucial. Critical does not mean crucial. It means that basically it's the longest path through a project. That's all critical path means. It sounds like critical path is all essential potential topics or tasks. All critical path means is the longest way through. And if you have two identical paths through the project and they're both longer than the other paths, yes, you can have two critical paths. And the critical path also, if the project changes, the critical path can change over time as well. So, in terms of how we use critical path to manage our schedule, slack or float, free slack or free float, free slack or free float, I should say, it's hard to say very fast, means on an individual activity. How far can you delay it without delaying the early start of the next activity? Meaning, for example, if we're in task 2 out of 6 tasks, do we have some wiggle room to be able to go back and take extra time on? Total slack or total float, however, means that you can have the total amount of time an activity may be delayed from its early start without delaying the planned project finish date. So free slack or free float affects the next activity in the chain, where total slack or total float means how much slack you got without jeopardizing the final date of the project. So free slack or free float is just about delaying the next activities. Total slack or total float is about delaying the entire project. We can calculate the critical path and the total amount of slack or float in each task by doing the forward pass, backward pass methodology. Now, there is a great illustration of this, and I'm not glazing over it, other than to say that we're going to cover the critical path analysis in the next lesson on its own. We're actually doing a complete module just on how to calculate critical path. Our text will walk you through this. I think our next lesson will give you a much more in-depth view on how critical path actually works. But you can see, if you compare this diagram and this chart, our text will show you how to calculate that. I, however, will show you how to calculate that in our next assignment. You can see, though, for each task, for example, there's free slack for that particular task, and total slack, meaning how are we affecting the end of the project. In this case, task A has a total slack of 2 days that we can have without affecting the end date of the project. Any of the activities that have no slack in them are part of the critical path. So how do we use critical path to shorten a project schedule? Well, we can use that path to determine, for example, are there ways to put more people or resources against a particular task to get it done more quickly? Can we crash activities so that we do more things at once? We can fast track or do them in parallel if they are tasks that do not require a prerequisite. In other words, if they're not in sequence, if we can do tasks simultaneously, we can reduce the schedule, for example. We start talking about critical chain scheduling. Although this is an older management philosophy, something that's been around for a while, I think it's pretty interesting how it applies in our modern workplace. It really is the idea of the theory of constraints to avoid multitasking. Think about how we multitask in our daily lives. I might be recording this lecture while I'm checking my email, while I'm checking texts on my phone, and pacing my office. I am actually pacing my office, but I'm not checking my phone, I'm not checking my email. And the reason being, when we multitask, if we've got the same people working on multiple tasks or multiple projects at the same time, it takes us longer to get things done, and we can put less dedicated resources. So this theory is saying, why not put more concentrated resources in on tasks to get things done in a more linear fashion and really concentrate on one task at a time? It seems a bit old school at times because it sounds like predictive project management, but on the other hand, it makes some sense because we can build in buffers, for example. It's really well illustrated. look at the three tasks up top without multitasking. So we've got task 1, task 2, and task 3 all getting done with dedicated effort without multitasking, as opposed to the way that we often sometimes multitask, that we've got task 1, task 2, and task 3 all going on at the same time. And in this case, we've got we still may hit the same guideline, but look how long it took us to get task 2 done. On the second scenario, it took us 25 days, where we got task 2 done in 20 days by putting dedicated effort toward. This is an oversimplification, but really the idea that we can avoid multitasking and have more dedicated time to get work done. Well, one of the key parts of this concept of critical chain scheduling is really playing it safe. We build in buffers, meaning that we want to make sure that we're giving conservative estimates and giving ourselves some contingency to be able to accomplish a task. And again, Murphy's Law basically says, and it is a cliche, if anything go wrong, it'll go wrong. So we assume that in this philosophy of scheduling. Parkinson's Law means whatever time you're given to accomplish a task, you will use up. Think about it yourself. If you've ever been working on a paper or a project for a class, if you had 3 days to get it done, you still find a way to get it done. If you had 5 days to do the same project, you would probably still use 5 days to get the project done. So again, a project buffer means that we are putting in time into our task to make sure we can get something done before it's due. Feeding buffers, in addition to that concept, means that we add those before the task on the critical path, meaning we want to make sure that we don't go any further than the required critical path, so we build in some contingency time. Here's a great example of critical chain scheduling in action. If you look here, the critical chain shows us what we actually need to get done. We've got the tasks that are delineated with X's that we do with limited resources, meaning we prioritize those and we get them done. And then we've also got the feeding buffer, the FB, which means those are areas which we've built in extra time so that worst case scenario we can still hit the path that we've laid out for ourselves. Then we get into what we refer to as program evaluation and review technique. Simply stated, PERT is used when we really have some uncertainty about how long it's going to take to accomplish a task or a series of tasks. And what we essentially do is come up with averages. We come up with averages in terms of what we think each task is going to take between the optimistic, most likely, and pessimistic types of approaches. So here's some formulas, for example, if you go with the weighted average. We take the optimistic time, add it to the four times the most likely time, plus the pessimistic time, we divide it by 6. And here's an example of it in action. It's a bit of a kind of a rule of thumb or back of the envelope type of engineering, but it's still a widely used technique, especially in very fluid or moving projects. In terms of agile schedule management, guys, we talked earlier and we talked a lot about Scrum. The biggest thing about agile schedule management means that we're going to be revising our schedule estimates a lot more often and in a more collaborative fashion because, again, we don't have a project emphasis so much as we have a product or a deliverable emphasis. So it's just a different way of scheduling, and we're doing it more often. For example, product owner defines and prioritizes the work to be done within a sprint, so we're scheduling more frequently. So in terms of controlling the schedule, we want to make sure that we are staying on time and on target. So the goals are to make sure we're reporting out, are we on schedule, and to control anything we can that's delaying or changing our schedule. We also need to be able to determine what caused the change and how much the schedule has actually been delayed. So again, the inputs here right from our text, project management plan, any of the work documents that we've built along the way, performance data about how well people are actually accomplishing their tasks, and again, organizational process assets like project management tools. So here's some reality checks for you. Whenever you're putting your schedule together, I always like to err on the side of caution. The more detailed your schedule is, the more variables you've accounted for, the better the chance you're going to come up with a realistic schedule that you can actually follow. And this is one, or actually two factors I'd like to hit on. The time to alert upper management that you're getting off schedule isn't after you've already completely destroyed your chances of finishing on time. Contact management early. Nobody likes to give bad news to anybody, least of all to management, but those folks, especially stakeholders and sponsors, may have additional resources or funds they can bring to bear. If you really want to keep your schedule in check, talk to the people who are on your team. I can't understand why more project managers don't ask for opinions from their team. So there can be lots of issues too in terms of keeping the project on schedule. How empowered are your people to make decisions on their own, to keep things from having to get held up by waiting for people to make decisions up the chain? Are you giving people incentives for being efficient? Are you prioritizing the schedule and keeping it on time and on task by rewarding people for doing things and behaving in such a way that actually improves your chances of hitting the schedule goals? Are you disciplining people who are not performing up to par, and are you working with folks? If you've got to negotiate to say, hey guys, we're going to have to pull extra hours this week to hit this guideline, I hope you've got some goodwill with your people, or they're not going to go to bat for you. Again, it's really great that we have Microsoft Project to help us build schedules, to build a project schedule. But if we're not keeping accurate information in the software, you have very detailed but inaccurate charts. So you've got to feed good information into Microsoft Project to get something good out of it. In terms of global issues, different countries have different perspectives toward time management and what constitutes a necessity, what constitutes a crisis. So when you're working in other cultures, it can be sometimes difficult to translate Western concepts of time and priority into other cultures as well. And sometimes adding additional people really doesn't help. If you've got more people standing around waiting to work, that's not getting anything done. So some words of caution. It's really easy to just rely on templates and think because you're putting everything into a nice Gantt chart, you're going to accomplish the tasks you've set out to accomplish. In reality, garbage in, garbage out. You've got to be able to make sure that you are actually following through with those tasks in real life as well. So don't view project management software as a fix-all. And finally, in terms of if you're using Agile or Scrum types of approaches, critical path and other kinds of schedule management tools have to be revisited frequently, and you may have to make more frequent adjustments as well. So summary. When we're doing time management, remember, time is the one construct that you have no control over. Scope and funding, you have some control over. Time is not something any of us can control, no matter how much we all wish we had more. It's one thing that even the richest person on planet Earth cannot purchase, is more time. And the processes that we've discussed are illustrated for you here. Folks, thank you for your time and attention, and have a great day.